Okay, class, that was a nice break. And I hope you're starting to realize that there are a lot of uh, little kind of like facts of algebra that you need to know. This lesson, as I'm starting to complete this lesson, I realize, yeah, sometimes you just have to get more comfortable with some of the rules of math and when is something positive only and when is it plus or minus. You just have to get used to this concept. You could see that in this lesson, there's a lot of practice. So just keep practicing, and that will allow you to naturally understand when do I have to provide plus or minus, like in this situation, and when is it just the positive. Okay, so let's get right to it. So again, all we're doing is we're trying our best to isolate our variable. So whenever you have a constant, that's always the first thing to go away. That's always the first thing you should cancel. We get b squared is equal to 64, and that actually makes us happy because we know 64 is a perfect square. I then am going to square root both sides because I want to isolate b, and I just want one individual b. And whenever you square root a square, you know that the output has to give you, or you have to provide plus or minus. I know that 8 is the first thing that we think about, but let's not forget about negative 8, right? Negative 8 squared is also going to equal 64. That was easy. Okay. So here, number 10, subtract 4. I'm going to move a little bit faster. Square root of x is equal to 5. When this situation occurs, we don't have to account for negative. There is no way that the number for x could ever be negative. All right, so I'm going to square both sides, and then you get x is equal to 25. When you solve for x squared, you have to give me plus or minus. When you solve for square root of x, you don't give me plus or minus. You just give me the positive. Hopefully you're starting to see that and you're starting to see the pattern of that. Okay. It says, consider the equation x cubed equals 27. Is 3 the only solution? So if we had more time, I would definitely let you guys try this. Is 3 the only solution? Would negative 3 in this case work? The answer is 3 is the only solution. Now, does anyone know why 3 is the only solution here? Has only, only one solution because x cubed is an odd function. And odd functions don't have that mirror effect. So there's no way that you could ever give me a negative 3 cubed for it to equal the same as a positive 3 cubed, because the cube gives you an odd amount of values to multiply, right? So since we have 3 things that we're multiplying, a negative times a negative times a negative will indeed be a negative. A positive times a positive times a positive, well, we know that that's a positive, okay? So odd functions always maintain the sign that they have. Now, x cubed can equal negative 8, right? That exists. X cubed can equal, what else do we have? Maybe 125, right? They can also equal negative 125. But the thing is, your answer for x should always be the same sign. It can only be one sign. Odd functions only have the same sign as their answer, right? If it's a negative output, that means your x value has to be negative. If it's a positive output, that means your x value has to be positive. Odd functions only have the same sign as their output. I should probably say output instead of answer. Okay. So now they're asking us to solve. You have to realize with x cubed, there is no such thing as no solution. Oh, I don't want to say no such thing. I'm sure there are cases, but in this case, you don't want to write no solution unless you're confident that there's no way that that could be, right? X squared, for example, though, or square rooting something, that could be a no solution. But when you're dealing with a cube root here, or just cubing something, typically those can all be solved. It's just like solving for X. Because do we all realize, class, that X itself is an odd function as well? Okay. All right, so let's get to it. You cube root both sides. You have to be very comfortable cube rooting 64. If some of us are not comfortable with that, you have to go to the previous lesson because it is assumed that you know what the cube root of 64 is. Okay, the perfect cube that is a factor of 64. Well, that's funny because the 64 itself is a perfect cube. Sometimes I even lose track of that. 64 itself is a perfect cube. And the cube root of 64 is just 4. Don't have to write negative 4, and you do not want to write negative 4 because negative 4 would not be correct. Okay. Now, what's the inverse operation to a cube root? Well, the cube root would be to cube. And you remember, you have to attach the negative. So here you would be able to write x equals, because the cube root and the cube cancel. And then you write negative 2 cubed. So I'll write it out for you just in case you're wondering what that looks like. Negative 2 cubed looks like negative 2 times negative 2 times negative 2, which is negative 8. And you're like, wow, I'm not really used to seeing a negative number that can fall under a root. But that's because we probably have more familiarity with square roots. So just realize that if it's an odd function root, you can have negative numbers underneath. But if it's an even function root, like the square root or the fourth root, you can't have a negative under there. Okay, let's cube root this part, 135. So I'm like now thinking, okay, what's the cube root of 135 simplified? Ooh, don't really know. I'm going to use my cheat sheet of all the perfect cubes. 135 is here. I go down to 125. I know it doesn't work. 64. No, 64 will never end in a 5. So then what about 27? Wow, that actually works, right? 27 times 5 is 135. So we know that it's the cube root of 27 times the cube root of 5, and this becomes a positive 3. We don't have to worry about plus or minus here. So this is 3 times cube root of 5. Again, I write it with a dot. You'll see that some people don't need that dot. They just put them right next to each other. But I just find it a little bit more clear when you know that it's not 33. It's 3 times the cube root of 5. Okay, let's go a little faster. Cube root, you know that this is the cube root of 64 times the cube root of 2. You know that x is equal to 4 times cube root of 2, because this cube root of 64 is 4. Here, I would multiply both sides by 2, and you get y cubed is equal to negative 64. And again, previously we'd be concerned, but since this is an odd function, you don't have to be worried. You just have to cube root it. And we know the cube root of 64 is 4. So we know the cube root of negative 64 is negative 4. Okay. Keep trying these. I subtract 8 from both sides. I get the cube root of x is equal to 5. And then I'm going to cube both sides. And does anyone know what 5 cubed is? You said 125. That is correct. And then also one thing that I want you to get used to doing is make sure that you also realize that you could plug in your value for x inside the equation, right? So 8 plus the cube root of 125 is equal to 13. Is that a true statement? The cube root of 125, well, 125 is a perfect cube. So Cube root of 125 is simply just 5. And 8 plus 5 is indeed 13. So I know I'm right. It's always good to double check, especially when you're using this much time and effort to do a problem. All right, so let's take a look at Juliet. It says Juliet solved the radical equation 2 plus the square root of x minus 5 equals 3, and her work is shown to the right. Did Juliet solve the equation correctly? I love these type of questions because it allows you to see the work of another student. Let's see. So Juliet first subtracted 2 from both sides. That looks good. So then you're left with this, which is a very good point. And how do you get rid of that root? Wow, look what Juliet did. She added 5 from both sides, but you can't just add a 5. I mean, it's fine to do that if you do it to both sides, but you realize that this does not cancel. You always have to cancel the root first before you could try to isolate the variable from the inside of that parentheses. Remember, I said in the previous lesson, your expression under a root is always protected with parentheses. So you would say the expression under the root is always protected with a set of parentheses. You must always cancel the root first before you try to isolate the variable. Attempt to isolate x. Okay, so Juliet tried to cancel the -5 when she should have actually squared both sides and then cancel the 5 later. Now, one other thing that I want to point out is, like I just said before in the previous question, let's say you did get x equals 36, right? Let's say this was a test or quiz. You did get x equals 36. Try plugging it back in here. If your answer does not work, then you obviously know that your answer is wrong. Like if I plugged in 36 in here, I would be getting the square root of 36 minus 5. And the square root of 36 minus 5 is the square root of 31. So we know for sure there's no way that 2 plus the square root of 31 is equal to 3. So x equals 36 is definitely wrong. There's no way that that's going to be true. So always check your answer. Okay? And then finally, number 19, it says, estimate the solution for x to the 4th power is equal to 20. Let's just shoot out some possible answers. Like, would 2 work? Well, what's 2 to the 4th power? 2 to the 4th power is equal to 2 times 2 times 2 times 2, which is equal to 16. Whereas, 3 to the 4th power would equal 81. So we know that x is in between 2 and 3, and it's heavily leaning towards 2. Let's just have fun with it. Let's call it 2.2, and let's see if it's right. It's just to use your calculator to estimate. We actually would need a scientific calculator for this. Those blue cheesies that we use in school are not powerful enough to find the 4th root of something. So let's go ahead and take a break right here.